Miss Sheila visited a store near her house and found that the glass jars are arranged one above the other in a specific pattern. On the top layer, there are three jars. In the next layer, there are six jars. In the third layer from the top, there are nine jars. And so on till the eighth layer. On the basis of the above situation, answer the following questions. Write an AP whose terms represent the number of jars in different layers starting from the top. Also, find the common difference. Is it possible to arrange 34 jars in a layer if this pattern is continued? Justify your answer. And finally, if there are n number of rows in a layer, then find the expression for finding the total number of jars in terms of n and hence find S8. Or the shopkeeper added 3 jars in each layer. How many jars are there in the fifth layer from the top? So this was the question. Now let's see the solution. On the top layer there are 3 jars. That means A is 3. In the next layer there are 6 jars. In the third layer from the top there are 9 jars. So common difference would be 9 minus 6 equal to 6 minus 3 equal to 3. And so on till the 8th layer. So n is 8. Now, first, write an AP whose terms represent the number of jars in different layers starting from the top and also find the common difference. So, AP would be 3, 6, 9, 12, 15, 18, 21, 24. And the common difference, as we found out, is 3. Now, the next part is it possible to arrange 34 jars in a layer if this pattern is continued? And justify your answer as well. So we know that an is a plus n minus 1 times t. Substituting the values of a, and d, we get 34 is equal to 3 plus n minus 1 times 3. That is, n is 34 upon 3, which is not an integer. That means it is not possible to have 34 jars in a layer if the given pattern is continued. Next part is, if there are n number of rows in a layer, then find the expression for finding the total number of jars in terms of n. Now Sn is n by 2 times 2a plus n minus 1 times t. Substituting the values of a and d, we get Sn equal to n by 2 times 3 plus n minus 1 times 3. Thus Sn is equal to 3n by 2 times n plus 1. For finding S8, we substitute n as 8 and we get S8 as 108. Let's see the OR part of this question now. The shopkeeper added 3 jars in each layer. So now AP is 6, 9, 12 and so on. So A is 6, common difference again is 3. AN is A plus n minus 1 times T, thus A5 is 18. Triangle is a very popular shape used in interior designing. The picture shows a cabinet designed by a famous interior designer. Here, the largest triangle is represented by triangle ABC and smallest one with shelf is represented by triangle DEF. PQ is parallel to EF. We have to show that triangle GPQ is similar to triangle DEF. Angle DPQ would be equal to angle DEF. These would be corresponding angles. Angle D is common in both the triangles. That means triangle DPQ is similar to triangle DEF. Next part is, if DP is 50 centimeter and PE is 70 centimeter, then we have to find the ratio of PQ and EF. Now DE is 50 plus 70, that is 120 centimeter. DP upon DE would be equal to PQ upon EF. That means PQ upon EF is 5 upon 12. Next part is, if 2AB is equal to 5DE and triangle ABC is similar to triangle DEF, then show that perimeter of triangle ABC upon perimeter of triangle DEF is constant. Now 2AB is equal to 5DE, we are given that. That means AB is 5 by 2 times DE. Now triangle ABC is similar to triangle DEF. So AB upon DE would be equal to BC upon EF would be equal to AC upon DF, each equal to 5 by 2, which means AB would be 5 by 2 times DE, BC would be 5 by 2 times EF, and AC would be 5 by 2 times DF. Perimeter of triangle ABC upon perimeter of triangle DEF would be AB plus BC plus CA upon DE plus EF plus DF. That means 5 by 2 times DE plus EF plus GF upon DE plus EF plus GF, which is 5 by 2, a constant. The last OR part is, if AM and DN are medians of triangle ABC and DEF respectively, then prove that triangle ABM is similar to triangle DEN. Now triangle ABC is given to be similar to triangle DEF, which means that AB upon DE is equal to BC upon EF, is also equal to half of BC upon half of EF, so BM upon EN. So also angle B would be equal to angle E because the two triangles are similar. That means triangle ABM would be similar to triangle DEN. Metallic silos are used by farmers for storing grains. Farmer Girdhar has decided to build a new metallic silo to store his harvested grains. It is in the shape of a cylinder mounted by a cone. Dimensions of the conical part of a silo are: radius is 1.5 meters and height is 2 meters. Dimensions of the cylindrical part are: radius 1.5 meters and height 7 meters. On the basis of the given information, answer the questions. First, calculate the slant height of the conical part of one silo. Now, slant height is given by square root of r square plus h square. Substituting the values, we get L as 2.5 meters. Now, find the curved surface area of the conical part of one silo. Curved surface area is given by pi r L. Substituting the values, we get curved surface area as 11.78 meters square. Next is, find the cost of metal sheet used to make the curved cylindrical part of one silo at the rate of rupee 2000 per meter square. Now curved surface area of cylinder is given by 2 pi r h. Substituting the values, we get curved surface area as 66 meters square. Now cost of metal sheet used would be 66 times 2000. So 1,32,000 rupees. The last part is, find the total capacity of one silo to store grains. Now capacity is given by the volume of cylinder. So it will be pi r square h. Substituting the values, we get volume as 49.5 meter cube.